So this is my quadcopter. This is the only one that I still have. I want to point out some things about this quadcopter. First, the green are the front props, and what's important with these are that they are opposite. So if you notice, the pitch of this propeller is high on this side and low on this side, but over here it's the opposite. It's high on this side and low on the back side. And the reason is they must spin uh, opposite of one another to cancel out gyroscopic effects. And so when you look here, the numbers are the pin numbers that you're connecting them to on the Arduino, but this is for a different layout here that I've got. This is a different circuit board. It's more like the one you're using. But the props need to spin opposite of one another to cancel out gyroscopic motion. If they all were spinning the same way, the whole thing would rotate like this in the air, and you would never be able to fly straight. So that's one key aspect with quadcopters that you need to understand in controlling them. The next thing is, if you look, I'm looking at the forward direction here. On the board itself, it says forward with an arrow. And that is supposed to be pointed exactly forward, because for a quadcopter to fly, the only way that they can move is to go forward. You have to tilt forward, and then you're propelling air behind you, and you move this direction. To be level, you stay level, but to move in any direction, you have to tilt to get a vector of thrust in the opposite direction of where you want to go. So if you are telling the quadcopter to tilt forward, but that's not oriented correctly with the controller board, maybe the controller board is sideways, like this. So if the controller board thinks that pointing toward me is forward, but the propellers are set up so that going forward is tilting where the green are, then it's going to kind of spaz out because it's saying, oh no, that's not right. I'm going to try to fix that. And when it tries to fix it, it's going to try to tilt its right side higher, because with respect to the board's arrow, that would be its right side. And so it would try to do that. But the right side of the quadcopter is actually this prop and that prop. So instead of fixing the error that it senses, it will actually just flip over. So you have to make sure that the arrow here matches the forward direction, and that matches where you've plugged your propellers or your quadcopter or your motors into, and the direction of the propellers. Now, if this is not hard mounted, if it's floppy, that's going to be the same problem. If it's not flat, then whenever you're trying to tell it to hover, the board is sensing that it's not flat. So it's going to send signals to try to fix that it's not flat. But everything has to be in alignment and hard mounted so that it will, whenever it intends to pitch forward, it will in fact pitch forward. And not just that it's doing that, but exactly how much it should pitch forward is calculated as well. So it's very, very important. Another thing is, when I hard mounted this, I did it with two-sided tape and some little foam pieces here. And I mounted it directly over the center of gravity of my design, so that the circuit board inside that little box is basically in the plane of where the propellers are, and right at the middle of the center of gravity. That is important because, again, it all depends on these kind of constraints. It could never work. It's too complicated for this thing to figure it out on its own. So we have to constrain these things in such a way that it only has a couple of options for being able to keep itself level, if that makes sense. And so, again, forward needs to be the forward direction. All the props need to be the correct pitch, and they need to spin in the correct direction for each of those pitches. And that has to match what your firmware is set up as here. so that you know pin 2 is your forward left motor and it's spinning counter or clockwise. Pin 5 is your forward front motor or forward right motor, and it's got to spin counterclockwise. And so whenever it tilts, then you know which ones of those motors to speed up or slow down to make it tilt correctly. And so there's a lot of things that have to be kind of constrained and in alignment. You might notice I've got zip ties here holding on some components. That's perfectly fine. The battery, this is my power distribution board. I always zip tied the battery in place or used Velcro for the battery, just like strapped a piece of Velcro under here. But that needs to be as centered as possible so that, again, it doesn't affect the dynamics of the quadcopter. But it also needs to be hard mounted. It can't be loose and floppy. The only thing that's loose or floppy on this entire quadcopter is these are some just wires that are unplugged, but they need to be plugged in, and the antenna. So just a couple of things are loose, but they're not actually like falling off whenever you're actually flying it. So I've just unplugged these plugs. They should be in here somewhere. I can't even remember which way they go, but yeah. So these are, I think, the motors themselves, and they should just be plugged in to the outputs. But everything else is on there pretty solid. Nothing is loose or wiggly, and you should be able to fly it once you get that worked out. After you get all this set, you need to do what's called tuning the PIDs. And I think I sent a link about that previously, but whenever you tell it to go forward, by how much should it go forward so that it doesn't flip itself or get overpowered by the wind or something like that? How much should it expend on control for any particular direction? So that's something that you do in part of the process of setting up your quadcopter.